initial velocity is one half of the V max, something like that. Okay. So is equals to one half of the V max. Oh my gosh. Wala ba? Hello guys! Hello everybody! Hello world! Welcome back to my YT channel. This is again your YouTube content creator. I am Nasir Eternal Voice. Okay, as I promised, we will be now introducing another topic. But I guess this is related also to physical chemistry. It's this is under physics. Okay, so you remember we have Henry's law. You remember talking about the pressure of the solution that states that the pressure of the solution is directly proportional to the, I guess, Henry's constant, like that, or the solubility constant. Actually, the Henry's constant there is the solubility constant, okay, or the concentration constant. So that is Henry's law, okay, something like that. You remember that one? Okay. Pressure of the solution is equal to the Henry's constant or solubility constant times the partial pressure of solvent, something like that. Okay, and we have also Dalton's law of partial pressure, something like that. Then we have also to get the partial pressure. For example, partial pressure of A is equal to the mole fraction of A times the total pressure, something like that. Okay, and now we have also this Raoult's law. Okay. And now we will be dealing with Raoult's law. So what is this Raoult's law? Okay, I'll be able to explain a little bit so that we can understand further what is Raoult's law. This is another law, because there's a lot of laws in science. Okay. Too much Arrhenius law, Dalton's law, Ludwig's Boltzmann law, a lot. Okay. Avogadro law, oh my gosh. Idea, no, gosh. So a whole lot of more. Now, this is Raoult's law. The spelling is capital R A O L T apostrophe S. Okay, the law, capital L, small letters A and W. Oh my gosh. Raoult's law. Is this the correct pronunciation? Raoult's law. Oh my gosh. Okay. So this is familiar in physical chemistry, really. Okay, guys, if for example, I have a liquid, again, where's the liquid water? Oh my gosh. Liquid water, please. Again, actual demonstration so that we can understand properly this kind of vlogging. Charot. There's water I drink already. Gosh. I have to get another amount of water. I will put this in the glass. Okay? So we can understand really pressure, the pressure. We can apply this in actual scenario or actual situation. Okay? Like this. And this is a glass of water, right? I have to drink small part. Oh my gosh. There's a liquid surface, right? And this water composes again hydrogen molecule and oxygen molecule. Hydrogen molecule plus oxygen molecule produce one molecule of water. That's why I have in my hand. Okay, something like that. And these molecules, guys, is highly volatile. Meaning to say, this will escape to the surface at the top of the liquid water and it will just evaporate naturally and normally. That's the meaning of volatility. Even if you will not heat this to a certain temperature, you will just put this here. The air, 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 will react to the above liquid surface of the water and it will reduce little by little the amount or the quantity of the water. Though it will take long, but it will reduce a little bit, okay, like that. Especially when you go outside, okay, and you put the glass of water in the direct heat of the sun, so it will a volume of the water. okay, through the process of drying and evaporation. Okay, so the liquid molecules will escape very fast compared inside the room. Okay, it's too slow inside the room. Okay, it will take you, I think, how many days or whatever. Okay, but it will really reduce the volume. Okay, if you go outside, it will reduce fast the volume of the liquid molecules. Okay. For example, this is one. The vapor pressure of my solution. This is a solution, guys, because a solution is composed of a hydrogen in this manner, hydrogen and oxygen. So this is now called a solution. So there is a vapor pressure of the solution. Okay. Now the vapor pressure of solution is here is high. Okay, naturally. Okay, the vapor pressure of the water plus the vapor pressure of the pressure of so the hydrogen and oxygen like that, blah, 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 so on, so right. Okay, now uh, this one I don't introduce a non-volatile solute. What do you mean by non-volatile solute? Okay, the non-volatile solute are those solid substances that you will try to add. For example, sodium chloride, sucrose, okay, sulfates, any kinds of substances. Could it be in aqueous or in solid? Aqueous means a combination of water and solid. That's meant of aqueous or solid substances at all. So any kind of electrolyte, shall we say, salts, right? Uh, Sodium chloride, sucrose, fructose, what else? So many things, right? Just only an example. If you add that one, the vapor pressure of the solution will change. Okay, will decrease because you add a non-volatile solute. Now, if I will draw this in a piece of paper, like this. So I have here a container of liquid water. Okay, so like that. This is a liquid water, and I have liquid molecules like let's say that like this. Okay, this one. This is water, right? So this is pure solvent. Okay, pure solvent. But the pure solvent class doesn't only refer to water. A solvent, so many things like pure solvent of ethanol, like that. Okay, pure solvent of chloroform. Okay, pure solvent of let's say any kind of liquids. There's a lot. Benzene, like that. Pure meaning 100% because it's pure. The concentration is 100%. Okay, like it's pure without any mixture at all with other substances, right? So this is a pure solvent. Okay, this one or extraction one. Okay, this is volatile solute. Okay, like this. Without non-volatile solute. Okay, like this. Okay, this one. The liquid molecules, guys, though it's really slow, it will just react with each other. After that, they will go to the above surface and they will escape into the atmosphere later. Oh, like this. They will go up. Okay, ganon, ganon, ganon. Upward motion, upward movement. So arrow up. Okay, arrow up. Meaning to say the liquid molecules are going to the top, of course. Okay, like that. So it will vaporize of its high volatility. Okay, now, case number two, I have a glass of water also, but I put now the salt, the table salt, sodium chloride. I don't have to put na. It's just only very self-explanatory that I put already the salt here in the water, right? Okay. Okay, this is adding now a non-volatile solute. So with non-volatile solute, which is specifically the table salt or the sodium chloride. Okay, with non-volatile solute. Okay, like that. Okay. Only a reminder, a solute, guys, is not necessarily mean always solid, because, for example, in a liquid-liquid mixture, one would it also. For example, if you mix ethanol and benzene, the two has solute there, and that is the situation we need to investigate, which is the solute through analyzing the density, the volume, the mass fraction, the mole fraction. In that way, we can determine which is solute. Because in chemistry, there's a definition of solute and there's also definition of solvent. That's why we have dilution factor, diluted substance, concentrated substance. So that means concentrated, more of solute, less of solvent. Diluted substance, more of solvent, less of solute. So that's the technical definition. How can we say a substance is concentrated or a diluted one? It's just like that here. So we have also here like this. I have still the water molecule like this. That I represent that, okay, like this, and I represent also the salt. Okay, the salt will be a star. This is only a representation. This is not only a real illustration. I put salt particles as a star so they can easily react with each other. Charot. Okay, this is a salt. Sodium chloride galore. Ganon. Di ba ang saya? Okay. Like this. Now guys, in illustration 1, the liquid molecules of water will easily go to the top. But in this second, there's a reaction of what will happen. These salt particles will reduce the motion and the movement of the molecules in going up because the salt has its own weight. Okay, when this salt reacted to the liquid molecules, it is not expected that the liquid molecules will turn into the vapor right away. There's a chemical reaction there, right? So especially the charges, okay? The charges of the water and the salt. So in this situation, guys, if that happens, so we reduce also the vapor pressure of the solution. Okay, meaning to say, technically in science, if we introduce a non-volatile solid to whatever chuba chucho in a certain solution, it will decrease the vapor pressure of the solution. Okay, that's very clear. Okay, we decrease the vapor solution upon adding the non-volatile solute, but without adding the non-volatile solute, the vapor pressure solution is still high. Okay, now in the first illustration without the non-volatile solute, this is not yet a Raoult's law. Okay, in the second illustration, this is now what we refer as the Raoult's law. So therefore, we conclude that this Raoult's law, it is the addition of a non-volatile solute and thereby decreasing the vapor pressure of the solution. That's the technical definition of Raoult's law. And now the equation will be like this. Vapor pressure of the solution, like this, is equal to the mole fraction of pure solvent, which is water in this case, because we use water as our actual demonstration, not the other solvent. So it is other solvent also in certain questions and different examinations in the future that you will be able to face, then use that kind of solvent also. Okay, but in here, in my discussion purpose, I only use pure solvent, which is water. So vapor pressure of solution is equal to the mole fraction of the water or the solvent. Okay, mole fraction meaning X water H2O times, okay, the vapor pressure of water or the pure solvent water. Okay. Now guys, you have to remember, okay? Like this, water. Now guys, you not mix this one, huh? Always think into account that if we speak about Raoult's law, that is mainly talking about vapor pressure. Okay? There's no partial pressure involved in this situation. It's always vapor pressure, the K terms in this particular topic of Raoult's law. Because sometimes you will be mixed up with a lot of gases, chupa, chucho, during the examination, if you face the different kinds of examination in the future, because there are partial pressures of the gas also, okay, or saturation pressure of the gas, superheated pressure of the gas. So that's also another story that if sometimes also in examination, they will mix everything there. Sometimes you will be confused. Me also, I'm confused all the time. Okay, but you have also to to think. Okay, that the applicability of the topic and the equation and the formula, so that you'll never get lost. In here, the Raoult's law are referring to vapor pressure of the solution and the solvent, something like that. Okay, that's very clear. Guys, how can you compute the mole fraction of water? Again, from chemistry, general chemistry lecture. Okay, in your high school and in your first year college. Okay, mole fraction, of course, it is mole, right? It's equal to the moles A over the moles total. Okay, something. A representing any kinds of substances that you are referring. For example, I add here sodium chloride. So the moles of sodium chloride, okay, plus over the moles of sodium chloride plus the moles of water. So this is the mole fraction of sodium chloride or mole fraction of the solute here, specifically in my example. But in the real law, we are not using the mole fraction of the solute. We are using the mole fraction of the solvent, specifically in my discussion. This is the mole fraction of water. Do not mix up, ha? This is always solvent, not the solute. Okay, in your equation. So moles of water over the total moles of water plus the sodium chloride. Because you mix the sodium chloride already with water, it becomes a chaos solution. Okay, or solvated or hydrated solution. That's the K terms, synonymous terms. The terms are first a chaos solution, meaning you add water. The second term will be solvated solution, meaning to say you add liquid. Okay, in your solute. Okay, and there's a solute and liquid. And the third will be hydrated, meaning there's a water solution. So sometimes it will be mixed up also interchangeably in facing future examination. Not only this word always used, aqueous, not only the time of aqueous will be used. Sometimes the hydrated solution of like this, for example, ethanol. Ganon. So it's not using the word aqueous, but in your instructor before, always using the word aqueous. And then you have no idea, right? So you have also to master the synonymous terminologies in its scientific term because it can be used interchangeably. Just like a velocity is like a rate also. Okay, solubility is just like a concentration because it can be used interchangeably pala talaga siya in different science equation. You have to take down that because in our college, our instructors will sometimes always using the same terms in the problems, and then it will be modified somewhere along the way. If you face certain examinations also, and you are not familiar already, so nga. Okay, so you should be clever enough to understand the terminologies. Okay, it would help a lot really guys that pass certain examination, to be frank. Okay, now going back to this, vapor pressure solution is equal to mole fraction of water times the vapor pressure of water. Okay, now we go directly to the problem solving para diretso na gid siya. Okay, wala na ilabad sa ulo. Charot. Okay. Okay, let's do this on the spot. Okay. As I told you earlier, I don't want to solve na gi-practice na ako daan. Okay, I want to solve on the spot to really challenge myself. Okay, something like that. And sometimes I change the given really. I change the given just to have my own attack. Oh, it's gonna be like this because I don't want to be dependent on the examples like that. Okay, so I'll manage to solve it first on the spot rather than looking how it is being solved. It's not challenging. That's why I don't want to have a scripted vlogging. As you can observe, I don't have a scripted vlogging. It's always on the spot. Okay, what comes on my mouth, then bingo, it should be delivered to my audience. Something like that. I don't have a systematized like this, 1, 2, 3, 4, 5, and it's perfect like that. And you cannot commit errors somewhere along the way. Me, as you can observe, I commit errors and I suddenly change because I commit errors. So that's how beautiful, because you will learn somewhere out there in your discussion, right? And it helps you to correct immediately what's on your brain cells, like that, your stock knowledge. Okay, because that means your brain cells are properly working. Okay, and it sharpened your mental ability on the spot also. So you are not dependent too much on what you see in different, reference books like that. Okay, as much as possible, we should avoid to be bookish. Okay, something like that. Okay, we need to have our own attack in solving the problems. Though, when you look at it, for example, it could not be denied that there are also problems that you will never understand talaga siya. Then even though you repeat it two times, three times, and then that's the time you look na how it is being solved. So that you will learn na talaga siya. But as much as you could solve it without seeing how it is being solved. Because in that way, you can really understand. Okay, you learn a lot, helping your brain cells, okay, to dig it up. Okay, those theories, principles, and concepts, and formulas and equations that are appropriate to solve a particular problem. Okay, now it's gonna be this an example for this Raoult's law. Okay, 84 grams of sucrose. What is sucrose? This is what I told you. In problem solving also, guys, especially in our course, they don't really have the chemical formula all the time. You should also sometimes memorize or understand that this is gonna be the sucrose, this is gonna be the ascorbic acid, this gonna be the citric acid, this is gonna be the stearic acid, this is gonna be the palmitic acid, this is gonna be the high density lipoprotein, this is gonna be the low density lipoprotein. You should know the exact chemical formula. Okay, so that you can solve the problem. You should not be dependent all the time in the handbook, okay, in the books like that, because it can consume you a lot of time in one question alone. Okay, so you can not solve properly on that. You will stuck up, really. You will stuck up in one particular problem because you don't know the chemical formula for it. Scanning. Where did I put that one? And then panic like that. Okay, and the proctor will go inside, into the top, into the backward, and like it's very stretched like that, and one set apart. So there's a lot of factors to consider during the actual examination. So better memorize na lang talaga siya with better understanding all the chemical formula. Yung mga simple chuba-chuchu lang. Okay? Get the point? So sucrose formula is carbon 12 H22O11. There are 22 atoms of carbon. Okay? There are, okay, you understand? Carbon 12 H22O11, sorry. 12 atoms of carbon. See, my brain cells really works so fast. Okay, carbon 12 H22O11. I commit mistakes, right? I said carbon 22 and I immediately changed to carbon 12. Okay, carbon 12 H22O11. So 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. This is the exact formula of white sugar in our kitchen. Okay, the white color we put in our coffee. So that is the chemical formula. And if somebody asks you, how many carbon in this sugar? Then you can say, there are 12 carbons, sir. Because you memorized already how many carbon atoms in the sugar. Ganon. The same as with sodium chloride. Ganon talaga dapat, di ba? Apply science in day-to-day life. O ganon. So going back to the sucrose formula, so carbon 12 H22O11, okay? I must write the chemical formula here so that we can understand easily and we can proceed further to the proper solution of this particular problem. Okay? Ganon. So Pero don't take so fast in your discussion. Sorry. Okay, like that. Okay, 84 grams, the mass. Oh my gosh. The mass of sucrose. Dito na tayo sa given, chuba-chu. Given or data. Ganun talaga yung problem solving. Data, given, okay. Like this. The given is 84 grams of sucrose. Okay. Ganon. So you should know also the formula of fructose, ha? Fructose, sucrose, galactose, maltose. And you should understand the behavior also, ha? Study biochemistry for that because there's a lot of changes of the atoms for that. Okay? Like that. And know the disaccharides, the monosaccharides. Okay? Before, right? Okay? Just remember that also. Okay? So 84 grams of sucrose dissolved in 100 ml of water. So we have 100 ml of water. Okay. Guys, this word dissolved is not necessarily mentioned all the time, ha? Because if you mix these two, not necessarily you will say dissolved because it's already mixed, right? The term not always dependent with the term dissolve. As long as it is being mixed, of course, it was dissolved already. Something like that, okay? Not word for word back, what I mean, okay? 100 ml of water, okay? And then what is the affected vapor pressure? And don't be afraid by the word the affected, it's just only a drama, okay? The word, the adjective affected prior to the words vapor pressure is only an adjective describing the vapor pressure. In English, adjective. Okay, beautiful woman, beautiful girl, smart boy, adjective, describing particular person or a noun. So it doesn't contribute to your solution here. Actually, I will just say, what is the vapor pressure at 27 degrees Celsius? It would be okay already, but the question put, what is the affected vapor pressure? To be artistic only, putting something different, okay, like a drama. But actually, it doesn't contribute to the how you solve it. Okay, this description only to the kind of vapor pressure you are solving for. Okay, like that. So the vapor pressure at what's this? 27 degrees Celsius of water. Vapor pressure of water. Okay, vapor pressure. Vapor pressure of water. Hala, vapor pressure of water is not given, but okay, there is a temperature. Okay, pressures, guy, directly dependent on those temperature. Ha, if there's a pressure value, then you can look for the temperature. So vapor pressure of water at 27 degrees. So if you try to look this, we have also value of water at 27 degrees Celsius. Okay, you will get that one. I don't have that one. How can I? I don't have handbook and I don't have books. I have no choice. I have to Google that one, right? I have. I don't have books now. I don't have also. I cannot exit in the screen also, so that I can go to the website and check the table for this. It's gonna be table 10.2 something like that in the Paris Chemical Engineers Handbook. I don't think so. I'm not memorizing the table, but it's there. Okay, the vapor pressure of water at 25 degrees Celsius is equal to like this. I don't know. I will try to apply algebra. On the spot niya, because I don't have references. I try to apply ratio and proportion na lang. Okay, so if we have temperature at, let's say, at, ano ba, sa air ba to? No, it's the water. Okay, if we have a temperature of, let's say, 25 degrees Celsius at room temperature, what will pressure? Guys, what will be the pressure? Let's say STP na lang. At standard temperature and pressure, so the standard atmospheric pressure is 1 atmosphere, right? So let's try if it works, ha? Okay. Ay, pinahirapan ko talaga yung sarili mo dyan. Okay. Because I don't want to go to... Okay. I don't want to go to the Google directly. I need to use my brain cells muna. Okay. Like this. If we have, sa ganito, absolute pressure, okay, absolute pressure, atmospheric pressure is equal to absolute pressure plus the gauge pressure. And then, and then the atmospheric pressure is equal to the gauge pressure plus the vacuum pressure. Something like that, if you can remember. Okay, now if we have the atmospheric pressure, so that is 1 atmosphere. Okay, for the atmosphere, how can we do for the water for this? Oh my gosh. Nakakaloka. Okay, so if we have the air and the water, that way. So, let's say air muna tayo. Ang atmospheric pressure sa air, sa atmospheric, kuan man siya. 1 atmosphere. 1 atmosphere at 0 degrees Celsius. Ganon. And now, for the water at standard temperature and pressure, pila man siya. Okay, since we know that at 4 degrees Celsius, at 4 degrees Celsius, we obtain a standard density of water which is equal to 1 gram per ml. Okay, but this is density. Okay, if we obtain density at 4 degrees Celsius, we can also obtain pressure at 4 degrees Celsius. How can we do that? Oh my gosh. The relation between pressure and density. Allah. Relation between pressure and density. Oh my goodness, too difficult. Okay, started with pressure is equals to force over area, and then we will consider the elevation pressure. Pressure is equals to height times the gravity. Okay, let's try this one. Pressure. Okay, there's a lot of formula of pressure, right? We have the elevated pressure, we have the pressure in terms of force over area, like that. Okay, so we have also the pressure in the Bernoulli theorem, right? So pressure is equals to, let's say for example lang siya, okay, my gosh, kaloka. Okay, so mmHg, sama na siya, mmHg. Di ba? Millimeters of mercury. Okay, so that is unit of pressure, right? Okay, so Hg. Ganun. So, what is the unit of gravity? Specific gravity. La, no, that's the specific gravity. Acceleration due to gravity. Sorry. So if I multiply the acceleration due to gravity, which is equal to 9.81 meter per second, hala, oy, times say the mmHg, what will be the result here? Okay, and we convert first the mm to meter, right? Something like that. So that it can have a unit of pound per square inch, right? Oh, this is pressure. So the pressure pound per square inch. Oh my goodness. So there's a mass. Okay, mass. Okay, so pressure is equals to the mass, right? The number shape pound inch. Okay, so the mass. So the mass times the density. Oh my goodness. Okay. Okay, I try to, ano lang talaga siya, I try to recall some, for to get the pressure formula. When we use this 4 degrees Celsius, what is our pressure at this point so that we can correlate that here in the vapor pressure of water at 27 degrees Celsius. Okay, water naman ni siya. Okay, at we consider here. Okay, so we do ratio and proportion in algebra, right? Because I don't want to go to the Google. Okay, like that. So pressure, and after that, let's compare our answer to the Google. It just basically the same, meaning my computation is correct, even though without using the Google. Okay, so pressure. So mass, mass, okay. Charot. Okay, so I said right, pressure is equals to mass times the density. Oh, chararat. Okay, so I will use the density, guys, in terms of pounds per cubic foot. Para lang dyan po makakuha o pound per square inch, which is the unit of pressure. Something like that. Okay, so, okay, mass. So, okay, density, na naman ko yung density. So, 62.43, right? Pounds per cubic feet. Chararat. Okay? Okay, and then you have to cancel that out. Okay, so so it's not a mass, it's a height. Ganon talaga siya gaya sa engineering. Okay, you have to adjust. For example, you have a wrong memorized formula, then if you times that one, oh, it's gonna not be cancelled. So you need to multiply it another quantity. This is the reason why that your memorization sometimes that's your guide only so that you can troubleshoot what is the correct formula for that. Because sometimes when you insert those units, it will be cancelled out and you will get what that quantity all about. It's a technique and strategy in engineering study, something like that. So in here, I thought it was a mass, okay? And then it is a height. So pressure is equals to height times the density. Okay, like that. Because if I multiply the density to a height, makancel mo ang feet. Ganon lang siya. Okay? Ang chuba chucho. The rest will follow. Ganon. Okay, so our height. So mo pala ni siya ang formula. Height times density. Ganon ba siya? Yes, elevation pressure. Okay? So if I have the height, for example, pila man akong ibutang ani nga height. Chararat. Okay? So, feet. So, cancel, so that will become your feet squared na lang na siya. Kaya naman kay feet ni Ari. Okay? Now, how can you obtain feet in this manner? Then you need to convert the grams per ml. Because through this grams per ml, you can also compute in terms of grams per cc or cubic centimeter. Since we know that 1 cubic centimeter is equal to 1 milliliter, and therefore it is equal to 0.001 liter. So we can say also that 1 cubic decimeter, DC is equal to 1 liter. Conversion factor. Okay, now I have to convert the milliliter into cubic feet because the unit of density in here is cubic feet also, right? So you can convert this one. How can we convert? Okay, let's go. Okay, chararat. Okay, feet times 62.43 pounds per cubic feet. Cancel, cancel. Okay, now this is hypothetical because we don't know the distance of the water. So this is not applicable siya. Okay, because this is elevated pressure and we don't know the water reference for this. It's just water, man. Okay, whether it is in the table, whether it is in the ground, we don't know the positioning because but this pressure is a positioning pressure, man. Elevation pressure. Okay, so di na siya so we need to get another assumption for this. Okay, so density is equals to mass over volume. Can we do something for that? Density is equals to mass over volume. Okay, so maglakot mo ko ng water. Kaya ang water man good guys, nalahit man good siya. Because you know, if you have the air at 0 degrees Celsius, which is 1273, makakuha volume nga 22.414 liters, ideal, right? And then the water is not 0 degrees Celsius ang reference standard. It's 4 degrees Celsius. That's why we have a standard density of 1 grams per ml for water, 1,000 kilogram per cubic meter for water, 62.43 pounds per cubic feet of water. The standard there is 4 degrees Celsius, not 0 degrees Celsius. So it's very hard to correlate having different temperatures. It's not the same really, but it's still called standard temperature in case of water. So I don't know what are our scientists work before. Sometimes I cannot understand. Okay, like that. Why? What if making all standard temperature as zero na lang talaga siya? Okay, and in the physical chemistry also, the standard temperature is not also zero. It's 25 degrees Celsius. Okay, in which you have to add 273. That's why we have standard enthalpy of organic and liquid at 25 degrees Celsius. So another standard to be used. What if it is equal only from the water, from the air, from the heat? They have also different STPs. Okay, but the pressure is just the same. Can anybody explain me to that? Okay, in general chemistry lecture, okay, the air standard temperature is 0 degrees Celsius temperature, and standard pressure is 1 atmosphere, okay? But the water standard temperature is 4 degrees Celsius so that we can obtain a density 1 grams per ml of water na ginagamit na to siya, halos, okay? Standard na usap yun. Okay, now in physical chemistry also for various inorganic liquids and chemical liquids, our standard also for temperature is 25 degrees Celsius, not the 4 degrees Celsius, and not the 0 degrees Celsius. But take note, the pressure is always 1 atmosphere. Why? That's what I want to find out. And when I go to my education in elementary level, high school level, and college education, nobody explains that to me. Okay? And when I search also for books or online websites, I can never find an answer for that also. Why? Okay, so this is gonna be, you should think why. So we should do our research for this in order to prove why it has been changed, but the pressure is just the same in different topics, chemistry, physical chemistry, physics, like that. Dugay na dyan ko nagibog, ana, but di mo dyan ako matubag na siya. Good, okay. Okay, especially in ideal gas, makalibog yun siya. Okay, but okay, anyhow, let's just do it as per the topic na lang yun siya, what is applicable, right? In here, Since we know the water is 4 degrees Celsius, our density is going to be like that. And the vapor pressure of water is 27 degrees Celsius. So what is the vapor pressure of water at 0 degrees Celsius? Hala. Okay, how can we determine that one? Okay, the vapor pressure of water at 27 degrees Celsius. Because guys, we don't know man go the standard pressure of water, but we know the atmospheric pressure, the air ba. So I think we cannot use ratio and proportion for this. Okay, because the ratio and proportion will only be good if there is at least one given. For example, air. I have one atmosphere pressure at 0 degrees Celsius, so that I can have a ratio and proportion here in this what I'm going to find out. But in here, there's no standard pressure at water. Sa water ba? Wala man siya. Okay, what is the pressure of water at 0 degrees Celsius? Okay, I don't encounter that one also. Okay, and what is the pressure of water at 4 degrees Celsius? I don't encounter that also, the theory. Maybe it can be computed through equation. Okay? So, dili na lang ako nabdo ng akong ulo. So, if I said, because I cannot use ratio and proportion, di ba? So, vapor pressure of water at 27 degrees Celsius. So, the last option is to consult a table or a graph in the books or any online sources. So, I must Google now. Okay, I will Google because, I cannot get it through, magsakit akong ulo. Okay, so Google. Siguro matubag ra siya, but it will take a longer time for me to analyze. And it will take time. Okay, so I must consult the Google. Okay, masakit yun akong ulo kasi mudig pa ko siya. Okay, like this. Okay, the vapor pressure of water at 27 degrees Celsius. Okay, Google. Ako rin siya i-Google guys because I have no other option. But as much as you could solve it by having your theories and principles using equations, everything you know, last option, Google. Okay? But in here, I have no other, siya. Okay? Talaga. Okay, how can I do this? Hala. Uy, in fairness. Uy, hindi ko ka-Google. Hala! Sorry. Okay, the pressure of water. Tempa muna ha. I should remember guys because I think one value for that at 25 degrees Celsius as far as I could know. Okay? Help me to analyze first because I don't have option. My battery is low bat. And I cannot Google also the vapor pressure of water at 27 degrees Celsius. So, but I remember one value for that. Okay, let me think at least 2 minutes. Gosh. Pinarapan sa sarili. Okay, like this. My gosh. Okay, if I say 1 atmosphere and then 1.013 bar, 760 torr, 14.7 psi. Okay, so like this. Okay, we will just use the 0. Okay, remember this last night, but we will just use this one, 0.0317. Okay. Okay, this is gonna be the value. Right, yes, because last night I solved it and the given is 25 degrees Celsius, but this is not the kind of problem I solved last night. It's not for the Raolt's law, another pressure problem solving, okay? Because before I do the vlog, I also go to another topic. Okay, that's my style. I go to another topic and then I vlog the previous one, something like that, so that I can prepare for the next vlog, something like that. But I don't really practice how it is being solved, something like that. But I remember it was 25 degrees Celsius is equals to 0.0317. Makaratio ang proportion na pala, buti na lang work on brain cells. Okay, or else I have to stop, right? Because You know, I don't have cell phone now. I cannot Google. Lobat. And I cannot exit in the screen just to Google my laptop. And I forgot almost all, correlations, how to compute this pressure. But I remember there's a 25 degrees Celsius is equal to 0.0317. Okay, so at 25 degrees Celsius of water, okay, thank you, Lord. I just remembered. Okay, at 25 degrees Celsius, our pressure, vapor pressure of the water is 0.0317 bar. Wow. Okay, now we need to know what is our vapor pressure at 27 degrees Celsius. So ratio proportion, right? Because the same quantity man siya. So 27 over x is equals to 25 over 0.0317. Algebra, ratio and proportion because the same quantity to be used. Okay, at certain temperature. Pareho siya ba? Okay, so we have 27 degrees Celsius is to, we don't know the pressure, and then equal to the 25 degrees Celsius in which we know the pressure, which is 0.007, and we can compute that, solve for the value of x. So this is our vapor pressure at 27 degrees Celsius because the same siya water. Okay? Like that, air, water, water. So in that manner, you can apply ratio proportion. But different quantity you cannot apply. Okay? Like that. So 27, charara. 27 times 0.0317 is equals to divided by 25. So our vapor pressure of water at 27 degrees Celsius is 0.0342. 0.0342. This is in bar. Okay, 0.0342. Okay, this is in bar. Okay, this is the vapor pressure of water, guys. Now, our formula, guys. Okay, our formula, guys. This one. Take note. Okay? Our formula, guys, is the vapor pressure of the solution equals to the mole fraction of the solvent water plus the vapor pressure of the water. We have now the 0.00342 bar. Our problem is the mole fraction of water. How can we solve that? We have given. Okay? Now solve for that. Okay? So, we have, asa naman to? Okay, 84 grams of sucrose. Okay, 84 grams of sucrose is not yet the number of moles. So how can we do that? So obtain the number of moles. How can we obtain the number of moles of sucrose? Again, use the molar mass. Okay, the one I told you before. Molar mass is equals to the mass in the numerator over the moles in the denominator. So use that formula. And the molar mass is equal technically to the molecular weight of a compound or an element you are referring. So bingo. So like that. So molar mass or molecular weight. So molar mass is equals to the mass, which is 84 grams for sucrose. Now, get the molecular weight of sucrose, right? You get the molecular weight of sucrose, then you can have the number of moles, correct? Okay, maro kayo siya. Okay, so ganon. So, 12 times 1.08 sa carbon, 12 times 12 carbon. Okay, and then 22 times 1.08 sa hydrogen. Oxygen is equals to 16. This is atomic weight, ha? Okay, like this, 16 times, pila man mo oxygen? Carbon 12, H22, O11, so 16 times 11. Okay, so get the molecular weight or the molar mass of sucrose. Okay, so 12 times 12 is equals to 144. Okay, 144, and then 22 times 1.08, 22 times 1.08 is equals to 23.76 plus 16 times 11. So how much? It's gonna be 100. Oh my gosh, too much. 16 times 11 is equals to 176. Really? Okay, so 176 plus 144 plus 23.76 is equals to our molecular weight or molar mass of sucrose or the white sugar is equal to 343.11 siya? 343.76. Okay. Grams per gram mole or grams mole, gram mole. Okay, so this is now, okay? So now compute for the number of moles which is in the denominator. Okay, molar mass is equals to the mass of sucrose divided by the moles of the sucrose. Then solve for the value of moles in algebra. You have to do the cross multiplication. So the number of moles will be equal to the mass 84 grams divided by 343.76 gram mole. Grams cancelled. What will left is the number of moles. Okay, we have now the number of moles of sucrose. So 84 divided by 343.76 is equals to 0.244. But take note, guys, this is only the moles of sucrose. Okay, how about the moles of water? So that we can determine the moles of solution, because mole fraction of solute is equal to the moles of solute over the moles of the solution. Okay, so we need to determine the moles of water also. So how can we do that? So the same thing, H2O, so 2 times 1.08, the molecular weight of water. So 2 times 1.08 is equals to 2.16. Oxygen, H2O man siya. Oxygen 16. So 16 plus 2.16, okay, equals to 18.16. Now we can do that. What is your mass for water? Okay, how can you compute for the mass of water? Okay, so you have now 100 ml of water. Okay, okay, so I have the number of moles. Okay, water. I will just continue this, moles of water, and then mass of water divided by the molecular weight. Okay, which is 18.016 grams mole. Then my problem here, I don't know yet the mass of water. Okay, the mass of water, so it's very clear, it can be obtained through the density of water. Katong giingon, at 4 degrees Celsius, we have 1 gram per milliliter of water, standard at 4 degrees Celsius. So use that one. So mass of water, density of water is equals to mass of water over the volume of water. Now, the volume of water is given in the problem is 100 ml of water. So, bingo, we can solve the mass of water. So, density 1 grams per ml times 100 ml, cancel the ml. Automatically, by equilibrium, the 100 ml is just equal to 100 grams. Am I correct? Yes. In this case, it just happened only. Okay, that the volume of water 100 is just also equal of 100 grams. Okay, 1 magutang density. Okay, like that. So mass of water, no, volume of water, mass of water, of course, like that. We need the mass of water, class, because that is our numerator here. That is our numerator, class, to solve the number of moles of water. And we don't have that mass of water. Since the problem was providing us the volume of water is 100 ml. But take note, guys, they don't mention the temperature, right? They don't mention the temperature, but we use the 1 grams per ml. That means up 4 degrees Celsius. Okay? Something like that. So automatically, kita siya, even though the temperature is not mentioned, and then we are using the 1 grams per ml. That means to say that is at 4 degrees Celsius. Okay? So mass of water, so density of water, guys. Okay, 1 times volume, so 100. 100 na siya. Okay, 100 grams. Okay, substitute that here, 100 grams divided by ganon. Okay, pila man sa water, number of moles. Okay, so pila siya. 18.016. 100 divided by 18.016. equals to 5.55 moles of water. So 5.55 moles of water. Okay, so we have now, okay, we have the moles of water, 5.55. We have the moles of sucrose, which is, pila to ang sucrose, 0.2243. So we can have now the total moles of the solution. MT is equals to 0.2443 plus 5.55. How much? Okay, 0.2443 plus 5.55. So this is now our N total. N total is equals to 5.7943. See, this is still our N total. So the mole fraction of solute is equal to the moles of solute, which is 0.2443 is here. Let's substitute. So 0.2443, okay, divided by the total moles of solute in which we obtained already, 5.7948. Then bingo, we can solve for the vapor pressure of the solution. Okay, ganon. Okay, like that. So 0.2443 divided by 5.7943 is equals to times 0.0342 is equals to our vapor pressure of the solution is equal to 0.000144 bar. Okay, this one. 0.00144 bar is the vapor pressure of our solution. Okay, now, if it is not yet added sodium chloride, what is our vapor pressure? It is 0.0342, of course. 1 times 0.0342. So how much it decreased? So 0.0342 minus 0.00144. So it will decrease to a matter of 0.032 pressure. When you add the sodium chloride, okay, into the glass of water, the original vapor pressure solution, which is equal to the 0.0342, will now become equal to 0.00144. So the difference is 0.032. It takes 0.032 pressure to be reduced. So meaning to say, the vapor pressure of the solution was being reduced upon the addition of a non-volatile solute called sodium chloride. So that is the principle of Raoult's law always had. Okay, please inject that already in our brain cells. Okay, that the vapor pressure of the solution will always decrease upon the addition of non-volatile solute. Now, if the case will say adding of volatile solute, so that's another thing to be investigated. Okay, because this is limited only to non-volatile. But still, it's also related to Raoult's law, but we need to investigate that, what will happen, because that is volatile solute man siya. But this law is specifically the non-volatile solute addition to a pure solvent man siya. Okay, so there's a difference. So we should not apply directly because it is not appropriate, it's not the same technically as the definition of the Raoult's law. But we can also try. Okay, but not really appropriate to use the Raoult's law. Okay, we don't know really if the answers in the choices are just close. If we apply this, it's gonna be like that sometimes. Okay, but we need to know that non-volatile solute here is being considered, not the volatile solute. Okay, like that. So makakibog sabi ko, a solute also is not always solid all the time. Sometimes it is a solvent. Okay. Normally in a liquid mixture. Okay, this is only this example only is good for liquid solid mixture. That's where your solute is solid. But in other situation, if it is a liquid mixture, your solute also is a liquid, and you will discover which among those two liquids are your solute. And there's also another situation that it's also a liquid gas mixture. And you should also identify which solute among this. It could be the liquid or the gas. It depends on the situation. Okay? Like how to compute or how to detect which is the solute. Okay. Sometimes also gas to gas reaction. And that there is also a solute between the two gas. So literally or technically, this solute is not does not mean only solid all the time. Okay, so it could be either in the other phases in different rare situation or in different occasions. But in here, we're not dealing yet pa for that. Okay, maybe it's another topic. Okay, we don't know yet, especially in distillation. You know, distillation and unit operation, because normally liquid and gas, something like that, the distillates, like that, the condensates, the distillates. So it's going to be the same, right? There's no addition of solid there. Always the water is being, heated up. That's why distillation. Okay, there's no solid involved. Okay, like that, something like that. Okay, this is the real slow. I hope you understand, guys. For this, shall I say long version? Okay, thank you so much. Bye bye, God bless everybody. If you like this video, then you can comment down below in the comment section. You can also subscribe my YT channel if you like. If you haven't subscribed yet, then you can click the notification bell for some latest updates that you will see here. Channel voice. Thank you. Bye bye. God bless everybody.